Hi everybody, it's Professor Mitchell. So now we are back to chapter 4, where we're actually going to start learning about the trigonometric functions. Now by the end of this chapter, actually for the next 3 sections, we're sort of going to learn 3 different definitions of these trigonometric functions. It is important to understand all 3. All right, sometimes you'll use one, sometimes you'll use a different one. Okay, so let's start looking at this. We're going to use the unit circle to define our trig functions. That's called the unit circle definition. We're going to talk about the domain and range of the sine and cosine functions. We're going to find exact values of the trig functions at pi over 4. We're going to talk about trig functions being even or odd. We're going to talk about some identities. We're going to talk about periodicity. There's a good word for you. And then we'll talk about how to do some trig with a calculator. Okay, so just a reminder, we touched on this before. Unit circle means a circle of radius 1, and we're going to put the center at the origin. So if you think back to a few sections ago when we talked about equations of circles, this equation right here, x squared plus y squared equals 1, describes a circle whose center is at 0, 0. So think of this as x minus 0 squared plus y minus 0 squared. And the radius would be 1. Remember, this number is r squared. So if r squared is 1, that means r is also 1. Okay? And we're going to use that unit circle to define our trigonometric functions. Okay, so in a unit circle, the radian measure of the central angle is equal to the length of the intercepted arc. All right, and the reason for that is you remember the equation theta equals s divided by r. Well, in a unit circle, r is 1. So theta equals s divided by r would just turn into theta equals s. So in other words, this number t and this number s are equal. All right, and actually, I wish they had just stuck with t for both of those. All right, but they're just saying that s and t are equal if the radius of this circle is 1. All right, so now we're ready to define our trigonometric functions. There are 6 trigonometric functions, and they are called the sine, the cosine, and the tangent. Those are the most important 3. And actually, the most important 2 are the sine and the cosine. You can talk about all 6 of these functions in terms of just sine and cosine. So understanding sine and cosine, I would say, is easily half the battle. Maybe even 60% of the battle. Tangent is another important one, and these ones are also important, but they relate very easily back to these other ones. So on this slide, they're just showing you the names of the functions, the sine, the cosine, the tangent, cosecant, secant, and cotangent, and then they're showing you how they're abbreviated. So they each have these 3-letter abbreviations. Okay. I usually, whenever I see any of the abbreviations, I almost always just pronounce them out. I don't think you'll ever hear me say cos or tan or sin. I'll just say sine, cosine, tangent. Okay, and here is how they are defined. So there's a reason that we have you take the trigonometry class and then have you take the pre-calculus class. Now in pre-calculus, we spend probably half the semester doing what's called college algebra, but then the rest of the semester we spend doing trigonometry. Hopefully not exactly the same trigonometry that you had in the trigonometry class, but trigonometry is so important for calculus that we just want you to learn it really, really, really well, okay? And so this looks kind of overwhelming the first time that you look at it, but you know, by the time that it's really critical to understand this stuff, you will understand it a lot better. So notice that t is the, well, it's the measure of this angle, but it is also the length of this arc. And again, I really wish that this letter here was a T instead of an S. I mean, it's not wrong. It's just, I think it would make it a little clearer if we made that a T. So what goes into any of these functions is either an angle or an arc length. And what comes out of this function is either an x value, a y value, or some kind of ratio involving x and or y. Okay, so the sine of t is just the y coordinate of this point. The cosine of t is just the x coordinate of that point. And of course, we're going to do examples. And then when you get into your other four functions, the tangent of t is y divided by x. And that's undefined if x is 0, because you can't divide by 0. Notice, I don't think it's too early to point out to you that the cosecant, the secant, and the cotangent are just the reciprocals of the sine, the cosine, and the tangent. You see that? So each of these functions is the reciprocal of the one that's written over here. Okay, so the cosecant of t is 1 over y. The secant of t is 1 over x, and the cotangent of t is x over y. Okay, so what are we going to do with that? That is the million-dollar question, and that's going to take up a good part of the rest of this chapter. So let's see. Oh, perfect, an example. Okay, so the point root 3 over 2, comma 1/2. Oh, finally they put the t there. I'm happy about that. Is on the unit circle, and they want me to use that information to find the values of the 6 trigonometric functions at t. Okay. All right, so I think they're going to go in the same order that we just saw them. So they'll do the sine first. The sine of t is just the y coordinate of that point, so the sine of t will be 1/2. Okay. The cosine of t will be the x coordinate, which is root 3 over 2. Okay. So if they give you this point, it's really easy as long as you either know the definition or definitely if you have it in front of you. The tangent of t is y divided by x. So I'm going to show a little bit of extra work there. Y divided by x is 1/2 divided by root 3 over 2. So the way that this turns into this is by, I guess the simplest way to say it is just multiply the top and the bottom of the big fraction by 2. So that leaves you 1 divided by the square root of 3. And then we just got done rationalizing denominators. The reason I put the rationalize the denominator section right before this is for exactly this reason. To rationalize the denominator of 1 over the square root of 3, I'm going to multiply the top and the bottom by square root of 3. And that tells me that the tangent of t is square root of 3 over 3. Okay. All right, so 3 down, 3 to go. We still have the cosecant, the secant, and the cotangent. So let's continue. The cosecant is 1 over y. 1 divided by 1/2 is just 2. The secant of t is 1 divided by x. 1 divided by square root of 3 over 2, think of that as the reciprocal of root 3 over 2, so that would become 2 over root 3. I rationalize the denominator, I get 2 root 3 over 3. And then finally, the cotangent of t is going to be x divided by y. Root 3 over 2 divided by 1/2, just multiply the top and the bottom by 2, you get square root of 3 over 1, which is just square root of 3. Okay, so now we have the domain and the range of the sine and cosine functions. So I'm going to point at this picture here a lot. And remember that the input for the sine or cosine function is this arc length. Or you can think of it as the angle, it really doesn't matter. So when they say that the domain of either one of these functions is all real numbers, they're just saying that you can think of this length as being any number. If you go around, you know what, let's talk about it in terms of the angle. That might make more sense. We just got done in 4.1 talking about angles. So if you go around one time counterclockwise, you get a number between 0 and 2 pi, right? If you go around a second time, then you get a number between 2 pi and 4 pi. Eventually, you can hit any positive number you want if you go around enough times. And you can also hit the negative numbers by going clockwise, right? So that's why the domain of either one of these functions is all real numbers. So any number, any real number can be thought of as an angle, either clockwise or counterclockwise. The reason that the range of the functions is the closed interval from -1 to 1 is because what comes out of the sine function is a y value. What comes out of the cosine function is an x value. Because the point xy lives on the unit circle, which has a radius of 1, that means x is stuck between -1 and 1, going that way, and y is stuck between being -1 and 1, going up this way. All right. So that's a really important thing to remember, that a number that comes out of a sine or cosine function has to be between -1 and 1. All right, so our first example, that's like this. Finding the exact values of the trigonometric functions at t equals pi over 4. All right, pi over 4 is a very common angle, and we've talked about it before. We talked about it in 4.1. So they want us to use this unit circle to find the values of the trigonometric functions at t equals pi over 4. Okay. So, for example, what that information will give you when you find the sine of pi over 4, you're finding the y coordinate of this point. And when you find the cosine of pi over 4, you're finding the x coordinate of that point. Okay. All right, so the first thing that they're going to point out here is that because this line comes up at a 45-degree angle, that is the line y equals x. We have not done any reviewing equations of lines in this class, but hopefully that's something you remember. And if the point if the line y equals x passes through this mystery point a comma b, that must mean that a and b are equal. All right, and that is a big, big, big clue to actually figuring out exactly what a and b are. Okay, and I have all the details right here. Okay, this point has equal x and y coordinates. Okay, again, because it lies on the line y equals x. So let's take a and b and plug them into the equation of the circle. Since that point lies on the circle, it has to satisfy that equation. And then because a equals b, I can take b and replace it with a. They're the same number. So that means a squared plus a squared equals 1. And that means that 2a squared is 1, just combining like terms. And if 2a squared is 1, that means a squared is 1/2. So just dividing both sides by 2. This slide is kind of explaining the y, the why of why the answer is what it's going to end up being. We're not going to have to do this thing that you're looking at over and over. If a squared is 1/2, that means that a is the square root of 1/2. Of course, a has to be positive. You saw that point was in quadrant 1. All right, and then we're going to rationalize the denominator. Okay, so they didn't show that part. You rationalize the denominator of square root of 1/2. Let's see, am I feeling brave? Shall I try to use the pen? Let's try it. Okay, and I'll do this right about here. So we have, we have the square root of 1/2, which is the same thing as 1 over the square root of 2. So that's using the quotient property of radicals. To rationalize the denominator, I'm going to multiply the top and the bottom by the square root of 2. Uh-oh. This pen has a mouse button on it, and sometimes I accidentally hit it. Okay. So multiplying the top and the bottom by the square root of 2. 1 times the square root of 2 is just square root of 2. Square root of 2 times square root of 2 is 2. Okay. So that's why on the next slide you see that point labeled as root 2 over 2 comma root 2 over 2. Okay. I'm going to try leaving that scribble there for just a minute. Well, no, I think it's going to get in the way. Okay. Okay, so we have now figured out that the coordinates of this point are root 2 over 2 comma root 2 over 2. And so now this is just like the problem that we did just a few minutes ago. I'll use my definitions of my trig functions to find the values of the trig functions at that value of t, pi over 4. So, oh, okay, we're not finding all of them. We're just finding certain ones maybe. So the cosecant of pi over 4, remember cosecant is 1 over y. So 1 over y would be 1 over root 2 over 2. The reciprocal of root 2 over 2 is 2 over root 2. And then if I rationalize the denominator, that turns into 2 root 2 over 2, which is just the square root of 2. Okay. All right, let's see what else we have. The secant of pi over 4. So the secant is 1 over x. And I think this is going to look familiar. The x coordinate of that point is also root 2 over 2. And once again, the reciprocal of root 2 over 2 is 2 over root 2. I rationalize the denominator. I get 2 root 2 over 2. The 2's cancel out. I'm just left with square root of 2. Okay, next we have the cotangent of pi over 4. Remember, the cotangent is x over y. Well, for this particular point, the x coordinate and the y coordinate have to be the same. So I can make this a lot simpler for you. Instead of thinking about this big ugly expression, just think of this as a number divided by itself. It's a number divided by the exact same number. And a number divided by the same number is always 1, as long as that number is not 0. 0 over 0 is not anything, but otherwise it works. Okay. Okay. So those are all the examples that they're illustrating, and then they've just sort of filled in the rest. But it's easy to see why these work. So the sign is the y coordinate. Remember, the y coordinate of that point was root 2 over 2. The same thing for the x coordinate. The tangent is y divided by x. Y divided by x is going to come out to 1 for the same reason that x divided by y came out to 1. It's a number divided by itself. Okay, even and odd trig functions. So here's a picture that I added. I found this on Google. Okay, it turns out, for example, that the cosine function is even. Remember, an even function is a function where when you replace, I'm going to say x, because that's how we learned it before. When you replace x with opposite x, you get the same exact function. Let me write that in here. I'm feeling a little braver about the pen these days. Of course, I probably just jinxed myself. Even means f at opposite x is exactly the same function as f of x. Okay. So let's talk about why is the cosine of opposite t the same exact thing as the cosine of t. Well, I'm sorry, in the picture that I found on Google, they used theta instead of t. It was still the best picture that I found, okay? So if you have a theta here, that gives you the point x, y. If you change that theta to opposite theta, it brings you down to this point, which would be x negative y. In other words, the x coordinate does not change, okay? So in this picture, the cosine of theta would be x, and the cosine of opposite theta would also be x, all right? Because these two x coordinates are exactly the same, okay? So that makes the cosine function even. The secant function is even because the secant is just 1 divided by x, all right? So if the x is not changing, then the 1 over x is not going to change either, okay? So those two functions are even. It turns out, interestingly, that the other 4 trig functions are all odd, all right? Let's talk about sine. When you look in my picture, it's not my picture, I stole it, but when you look in the picture at sine theta would be y. Sine opposite theta would be negative y. The y coordinate of this point is the opposite of the y coordinate of this point, all right? So that's why, all right, this thing here in my picture would be negative y, and this thing over here would also be negative y, okay? So just think of it as the x is going to stay the same, the y is going to become the opposite, and that's why these other ones are all odd also, because tangent y divided by x will turn into negative y divided by x. 1 over y will turn into 1 over negative y. X over y will turn into x over negative y. Okay, so here's an example where we're going to use some even and odd properties. They want me to find the value of the secant of negative pi over 4. Okay, so we just saw that the secant is an even function, which means the secant of negative pi over 4 is exactly the same as the secant of pi over 4. Okay, and we already figured out that the secant of pi over 4 is square root of 2. We already did that. Okay. All right, what else do we have here? The sine of negative pi over 4. Well, secant is an even function, sine is an odd function, which means the sine of negative pi over 4 will be the opposite of sine pi over 4. That's what makes it odd. And we already figured out that the sine of pi over 4 is root 2 over 2, which means the sine of negative pi over 4 is negative root 2 over 2. All right, so this is a reminder of the definition that we've already seen. Okay, I'm not going to repeat this. The reason that I'm showing this to you again is because, let's see, this is going to be helpful for a set of identities that we're about to look at. So one thing you can see from this is that the sine and the cosecant are reciprocals of each other. One of them is y, the other is 1 over y. The same for the cosine and the secant, the same for the tangent and the cotangent. Those are reciprocals. And then the other thing that you're going to see on the next slide, see how the sine is y and the cosine is x? That means instead of writing tangent t as y over x, I could say that the tangent of t is the sine of t over the cosine of t. And that is exactly what I am going to say on this slide. Okay? Sine and cosecant are reciprocals of each other. So are cosine and secant. So are tangent and cotangent. Those are called reciprocal identities. Then you have your quotient identities. Again, think of that as the sine of t is y, cosine of t is x, the tangent of t is y over x, and the cotangent of t is x over y. Okay. So we're going to use those identities to do this example. So if you're given that the sine of t is 2/3 and the cosine of t is square root of 5 over 3, that is enough information to figure out the value of the 4 remaining trig functions. So let's see how that goes. First we have the tangent of t. So let's take this step by step. The tangent of t, according to a quotient identity, is the sine of t divided by the cosine of t. They told me that the sine of t is 2/3. The cosine of t is root 5 over 3. So now we're just cleaning it up. So you could either think of this as dividing by root 5 over 3 is the same thing as multiplying by the reciprocal, or you could get directly from here all the way to here by just multiplying the top and the bottom by 3. Okay? So that'll give you 2 over the square root of 5, and then if you rationalize the denominator, you get 2 root 5 over 5. Okay. Let's see, next will probably be the, oh, okay, not what I was going to guess. The cosecant of t, the cosecant is the reciprocal of the sine. The reciprocal of 2/3 is 3/2. Okay, that one's pretty simple. Next we have the secant. The secant is the reciprocal of the cosine. The reciprocal of root 5 over 3 is 3 over root 5. And then if I rationalize the denominator, I get 3 root 5 over 5, which I believe leaves just cotangent t. The cotangent, oh, okay. There's actually 2 different ways you could do this one. They did it with a reciprocal identity. They said it's the reciprocal of tangent t. And we figured out earlier that the tangent of t is 2 root 5 over 5. So the reciprocal of that is 5 over 2 root 5. And then if you rationalize the denominator, eventually you get root 5 over 2.